Hi, friends. We've been working and thinking about parallelograms for a while, and I think we're to the point where I'd like us to be able to write a rule that we can use to find the area of any parallelogram. And we're going to be using Math Practice 7 as we think about this, simplifying problems by using their structure, okay? So what I've done is I've set up 4 example parallelograms, and we're going to take some notes on that. And you're welcome to, if you want to pause the video right here, and if you want to sketch this this little chart into your math journal, so you can take notes with me, that would be great. If you learn better by like watching and thinking and then doing your notes later, that's fine too. But it'd be really helpful at the end of this video if you could have the examples or some examples and the rule written in your math journal. That way you have it and you're not going to lose it. Cool. Okay. So parallelogram A is, we know it's a parallelogram because we have 2 sets of parallel sides that are the same length, and opposite sides are, or excuse me, opposite angles are congruent. So I know that I have a parallelogram here. It also happens to be a rectangle. Okay. So here, this side is the base, which looks like 1, 2, 3, 4. So the base for this one is 4 units. And then this side is the height. Oops. Height. Things are going crazy. Which looks like 1, 2, 3, 4, 5, 6. So the area of this parallelogram A is 4 times 6, which is 24 square units. Okay. That was pretty easy. So B, the base of this parallelogram, I could choose either side to be the base, but I'm going to choose the side that's easier to count. This side right here, it's hard to count the length of that because it's a diagonal side. So it might not have a whole number sides or a whole number lengths, but I do know that if I choose this side for the base, that's going to have a whole number side, and that is 1, 2, 3, 4, 5. Base is 5. And then so this is where we're looking at structure. If I were to take scissors, and if I were to cut that piece off there and move it over here, I have now created a rectangle, and the height is this distance right here. Height, which looks like 3. So the base is 5, and the height is 3. So the area of that parallelogram is 15 square units. Okay. C is a little trickier. I'm still going to use, because it's really hard to count the length of this diagonal side, I'm going to use this bottom, this base, which is 2. Okay. And then this is still, so if I were to cut it here and move that over here, and cut this piece here and move it here, you can see that I've moved this piece here, that piece to the top. I've made a rectangle that has a base of 2. The base is still 2. It moved, but the base is still 2. And the height is 1, 2, 3 units tall. So that area is 6. Okay. And then for D, looking at D, the diagonal side is going to be hard to deal with, but the vertical side here, that's actually going to be easy to count. So I'm going to call that my base. That does not look like the word base. Let me write it more legibly. Okay, so my base looks like 1, 2, 3, 4. Okay, and then my height, if I were to take with scissors and cut that piece off and move it physically to over here, the height is going to be 2. It's going to be 2, so then the area of that parallelogram is 8. Okay, so really for any parallelogram, and this is what I wanted you guys to notice, okay? I'm going to maybe, oops, I'm going to draw on these again, but I want kind of a clean slate. Okay, for any parallelogram, they have 3 dimensions. They have the base, maybe I'll just draw an arrow, that's easier. They have the base. They have, this is called the slant height or the diagonal side. Which is not generally very useful for finding area. I don't know what just happened. That's not generally very useful for finding area. But what is useful for finding area is the height. And the height is the distance, the shortest distance from the base up to the top. So I could measure the height here, 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 here. I could even measure the height out on the side there. Wherever I measure the height, these are all the height. The height, anywhere I measure it, is going to be 3 for that one. Here I've got the base. And then for this one, I'm going to have to come out here for the height. Or I could come over here for the height, I suppose, as well. But that's still 3. And that little like boxing that I'm making, height. You can measure it here. You can measure it there. The little boxing that I'm making is indicating that it makes a 90-degree angle. So like if I were to extend that line from the base, the height is perpendicular to the base. And then for part D, I'm calling this side the base. So then the height is going to be the line perpendicular to that. So this is the height. Okay, so for any parallelogram, let me just draw any parallelogram. Pretend that's a parallelogram. That's not a very good one, but that's fine. Okay, this is the base. And then the height, I'm going to do that in green so we can really notice that the height is that like distance from the base up to the top. You could also think about it as the distance between the two, those two parallel sides. And the reason this works is because if I were to cut that side off and move it over, I would make a rectangle, and the base would be still the same length, and the height would be that green line. So any parallelogram, the area is going to be the base times the height. And this makes sense. I hope that this looks familiar to you. This is the same as finding the area of a rectangle. Excuse me, my throat is really dry. Area's base times height is the same as the area of the rectangle, which makes sense. This is kind of the structure that I wanted you guys to notice. It's the same as the area of a rectangle because when I cut off that triangle piece and put it on the other side, what I create is a rectangle, okay? The thing that's different is that the height is not the side length, the slanty length. This is not the height. that slanted length is not the height. The interior, like that vertical space, is the height. So you got to pay attention for that. So the area of a parallelogram, area is base times the height.